the definition of the derivative. So let's do a review. If you have a function, you have a linear function here, f of x. Now, how do you find the slope of this linear function? Now, the slope is y2 minus y1 over x2 minus x1. So this first point right here, it has an x coordinate x1, y1, and the second point has x2, y2. So that's how you find the slope between these 2 points. Now, as we keep going down, instead of using x1 and x2, what did we say? The first point is x1, and instead of y1, we're going to say f of x1, right? This is the same as y1. Now, the second point, instead of saying x2, we're saying this second point is h unit further down from x1. So this right here is now, the new x2 is now called x1 plus some kind of h. And the y coordinate at that point will be f of x1 plus h. Now, if you just look at this new picture here, how do you find the slope between these 2 points? So the slope will be equal to y2, which is this is new y2 minus y1 over x2 minus x1. So here it is, f of x1 plus h minus f of x1 minus x1 plus h minus x1. Now notice x1 cancels out, so you're always going to the slope between these 2 points in this new fashion here, using the function in x plus h for x2, you always have h on the bottom. Now, what we just did is now the same graph like before. So when you look for, when you have like two, you're basically looking for the slope of between 2 points. But what if we let h go to 0? So as h getting smaller and smaller, basically this point is getting it's getting closer and closer to that point. So the minute it gets so close as we take a limit, basically, as let h approach to 0, then we can find a slope at this point. That's what derivative is. Derivative is finding a slope at one point, one specific point on the function. Now, we always learn that you cannot find a slope unless you have 2 points. But in this case, since you want to find one, so what we're going to use is using the idea of a limit. So as we let h gets to closer and closer, right? So as this point moving down, and you keep moving down towards x1, and you can keep finding the slope. But the minute you hit basically x1, then that's when you find a slope at that specific point, we call that slope at that point the derivative. Okay, so here's the equation. Limit as h approaches 0 of f, this is y2 minus y1 over h. Over h, because your x2 minus x1, basically your x1 cancels out. So here's your equation. Okay, here's your definition. Definition of derivative using limit. Now, so let's look at a couple of examples. Okay, so first one we can say find the slope of a tangent line. Now this line right here, that's the slope, right? At that point, also known as the tangent line. Tangent line is the slope to the curve. So when we say find the slope of a tangent line, basically we're finding the derivative of this function. Okay, another name for that is slope of tangent line. So, all right. So we want to find the slope of tangent line of f of x equal to x squared at 2, 4. So here's our quadratic x squared. At 2, 4, this specific point, I want to find the slope at that point. All right, so we know that f of x is x squared. Now we want to arbitrarily find a point that's h unit further away from x, right? So this is going to be our y2 y2. This is y1, right? Okay, so it's going to be, so whatever you see here, we're going to do x plus h squared. So we're going to FOIL this. You get x squared plus 2xh plus h squared. Now, by using the formula says fx plus h minus f of x over h. Here it is. And we're going to let h approach 0. All right, so rest of it is algebra. Okay, so we're going to cancel out our x squares. Okay, and then we can what we can do is, well, it says we want to find it at what, 2, 4, right? So x equal to 2. So we're going to go ahead and plug in 2 into x here. Okay, and then notice that now I have this equation with h only. Now we can divide by h everywhere. So we end up 4 plus h. Now its limit, h approaches 0 of 4 plus h. We'll simply just plug in a 0, then it equal to 4. So the slope of a tangent line, So slope of this red line here basically is equal to 4, also known as a derivative. Okay. Now we can also say, okay, let's change your language a little bit, but it's really the same question. Find the derivative of f of x equals 3x squared at 448. So I just want you to get used to the idea that derivative, okay, the physical meaning is the slope of the tangent line. It's the same thing. Okay, so we can easily say find the slope of a tangent line to the function 3 of x squared at this point 448. Same question. So I have step 1, you have the original function. Step 2, you to write a new function, let x equal to x plus h. You expand it out. Now third step, you put it in the definition, limit as h approaches 0 of f of x plus h minus f of x, those are the two things here, over h. Now rest of it is just simplifying using algebra. Okay, so what we have here is 3x squared cancels out, and then we can plug in the x, right? Okay, because they did tell us that x is equal to 4. So let's plug in the x so we only have the h to deal with. Then once we get rid of the x, you can see that we can divide out h. We can factor cross out h, right? Cancel out h. So you get left with 24 plus 3h. Now let's take the limit as h approaches 0 of this new function here. You get 24. So the derivative of f of x equal to 3x squared at 448, the answer is 24. All right, let's try another one. Okay, something a little different. Now you have a quadratic function, 3x squared. So that's the first step, right? Copy the original question function, and then step 2, just take the function and then let f be of x plus h. So you expand this out. Okay, so it's basically x plus 3x plus h squared. So here it is. Once again, using the definition of derivative, limit h is approach to 0. Take the f of what is the bottom function, f of x plus h minus the top one function here, 3x squared. In other words, y2 minus y1, right? Over h. All right, so we're going to do pretty much the same thing as the one before. Okay, after you cancel everything out and plug in the x. Okay, now notice it doesn't have an x in here. The difference between this question and this question, it didn't specific saying at a certain point. So you're just looking for a general equation. So this can be found anywhere on that curve. You're looking for the derivative of anywhere on this curve, and then all you have to do is, if you ever want to evaluate it, you just plug in the x, right? So this time we didn't cancel the x, so you end up with it, but you can cancel the h, right? So h, cancel it out, you're left with the 1h here. So 6x plus 3h. As h approaches to 0 on the limit, this second term will go away, so the answer is simply 6x. So 6x is the derivative of 3x squared. Okay. All right, now let's try something a little different. What if your function is radical x, right? Okay, it's fine. Okay, so this is a function is radical x. Then f of x plus h is radical x plus h. Use the same formula, derivative. Now this is new. Now this is a new symbol here. If this is the function, if you do a little prime right here, that means this new function in red here means derivative. Now take that derivative, its limit, right? H will approach 0 using the same definition. Take this y2 minus this y1 here over h. Now, how do you deal with this? You need to conjugate. This way, if you still remember your algebra days. So in order to get rid of these radicals, you need what? You need to conjugate. It means what? 1 minus 1 plus. You do that top and bottom. Basically, you multiply by 1. You're not changing anything. No, you're literally going to FOIL this out. If you FOIL this out, this times this, right? The first term, since it's x plus h square root and square, so that goes away. And so so continue doing that, right? Okay, once you do everything, you will see the middle term goes away. It's basically a minus b times a plus b. So the answer is what? A squared minus b squared. So this square is right here minus that square. So we can either use the formula a minus b times a plus b equal to a squared minus b squared, or you can just FOIL it out. In the bottom, I'm just writing down what I see here. So h times is everything here, right? Now when you do that, you notice the top x cancels out, so you only have h. Then h can go ahead cancels out. So that's all you have. Now, once you let limit as h approach to 0, so this is 0, so you end up with 1 over 2 radical x, and that will be the derivative.